And we'll start directly with the same trend, the digital ocean, so we can show that the economy in the sea can thrive while at the same time respecting the environment and giving the necessary tools to the decision makers. Well, we have digital tools, so we can actually model the potential scenarios for the future of the oceans. And we learn much more about this thanks to Yann Drillet from Mercator International. Good afternoon, everyone.
Bonjour à tous.
Good afternoon, everyone. Thank you for the invitation. My name is Yann Drillet. I'm the Director of Research and Development at Mercator Ocean. And I'm also the scientific coordinator of something called Editor Model Lab, where we develop new modeling components that will be integrated in the digital ocean and try to find answers to potential what-if scenarios. What would happen? Sorry, just waiting for the screen to display my slides.
Ah, ok. Donc voilà le type de cette présentation vers les jumeaux numériques
the title of this presentation is called Towards Digital Twins.
Donc qu'est-ce que c'est un jumeau numérique?
Multi-coupled
Donc c'est quelque chose
digital twins. What are digital twins? Something that was used in the industry, and the idea is to create a virtual model representing something physical or a process. So this kind of digital tool was created to have simulations.
Okay.
Oh, right.
Pour générer des simulations, mais aussi pour faire de la
To
maintenance, de la
do
surveillance de
modeling,
certains
simulations, maintenance, and so on. So we have the example of wind turbine. It's a good example of something physical, a tool, or something that we would like to model. And then we can try to improve the capacities of these tools. And the question is how we're going to adapt this concept of a digital twin to the oceans. And obviously it's a very complex environment. We have spatial scales and time scales, and we also have living creatures in it. So we all have observations, but they tend to be quite limited as far as we know. So this what we want is have to have a copy of a twin, in order to we can try out some scenarios, and so we need to have observations. We want to make sure that all can be compiled into data that we can use with digital calculators, so we can have good modelings, good models, and so we can acquire more knowledge. And the way is the reason we do all this is to make things easier for decision makers, so we can take the best decisions, and we can add more data so we can take more decisions. So this is a loop we try to create with what we call the digital twins. So how can we define these scenarios? Well, first of all, we need to identify the potential changes. We need to try a few things in the oceans. And we start obviously with some knowledge and what we can identify, and we can determine the potential changes. So I will give you a few examples as developed in this Editor Model Lab project. 4 different scenarios about what may happen with climate change. And this is once again essential. What may happen if we change the way we observe the ocean? How will we change the way we consider the oceans in our digital models? What could change if we change our own environment surrounding us? What are the potential infrastructure we can have in the oceans? And what may happen with pollution? These are the main pillars that we rely on to have this project. Then we need to be able to ask precise enough question, and at the end of the process we can define a scenario. And so we need to rely on all the knowledge available, and we can have everything put into an equation, and we can enter all the data in the calculators, and then we need to explain our findings, read and understand the findings, and it's an essential step so we can communicate and talk about the potential impact of climate change on the oceans. I'll give you a short presentation of the models we developed in this project and how we use them to have these what-if scenarios. So we wanted to have different scales, time scales and space scales, and we wanted to have different approaches. So right at the center of this we have the global ocean, and with a resolution of approximately 2 to 3 kilometers, and we're doing quite well even now. Then we have other scales, regional scales, the scale on coastal areas, coastal lines, and we have interactions with various components. So the observations, the rivers, the oceans, the seas. How we're going to use AI to improve some parameters, or maybe to use them for variables, and how we're going to use all the models, like for biochemistry, how we can simulate a pollution or shipping roads, and we try to develop some types of models. And this is just a short example of what we can do with these models. So we have the surface currents, and this is not very high resolution model. We can be even more precise on the regional scale, and you know that with these models we can actually highlight the currents and how it happens in different areas. So with the European seas and the oceans. So this is something we can use today, regionally and globally. And on top of this, we can use biodiversity data. So we have data on sea turtles, and we have the place of birth, and we can simulate the whole life cycle of these turtles, and we see how they migrate from one side of the Atlantic to the other, and we can test various scenarios based on changes in the temperature, in the environment, and the available food. They are very important criteria to study the migrations of turtles, and see the sea routes and fishing, etc. So I'll give you 4 specific examples of what-if scenarios that are available on the slide. So the first example. I think it doesn't work. Usually it should be an animation. All right. Okay. This is one of the applications we developed to see what is the way, the impact it has on the way we show and display the ocean. And there's an example of altimetry and how we represent altimetry with the new SWOT satellite. How can we integrate these observations in our models? And you have a final illustration which is quite interactive. And on the left-hand side is the way we represent the ocean now with the main satellites we've had for quite a few years. And on the right-hand side, what happened if we had another 3 satellites, which are to represent Gulf Stream the same way? But everything is going to happen differently on a more granular scale, so you have to go deeper in more details, and you have a better definition, a better resolution. It's thanks to the SWOT altimetry
qui nous permet de
with a much
représenter
better definition.
la méso- et subméso-échelle dans nos modèles.
And we can represent the mesoscale and the submesoscale in our models. And this is a good example of what happens if we can improve our modeling approach. Secondly, what happens if climate change happens, and probably not on all the variables. So we looked at the fish stocks, and most notably tuna fish. So you have an animation. Unfortunately, I cannot start it.
Je sais pas si voilà, ça bouge. Donc c'est aussi une application qui a été développée à partir
It's another application we developed based on the scenario
donc le scénario le plus pessimiste dans ce cas-là,
prepared by the IPCC. It was the most pessimistic scenario.
Qu'est-ce qui pourrait se passer
What would
les
happen
stocks de thon dans le Pacifique
in
tropical et puis en fonction
tuna
des
fish
différentes zones
stocks
économiques
in Pacific Ocean? What would be the effect on the various economic areas?
Sur l'échelle, la simulation qui évolue.
And see and scale how the
une grande diversité,
evolution
une grande variabilité
is ongoing, and see a high variability of the number of tuna fish in
vers l'est du bassin
several
Pacifique et donc
areas.
des endroits où
And
dans
they tend
ces
to
zones
migrate
économiques où
towards the eastern
on a
part
quand même
of the
un gros
Pacific
changement
Ocean.
par
So
rapport
you see we have
à ce
some
qu'on a aujourd'hui en
very
termes de
drastic
ressources
changes compared to what we can
disponibles.
observe nowadays and the available tuna fish
Ensuite, un
in
troisième exemple,
each area.
c'est
Moving
qu'est-ce
on
qui se
to
passe
a
si,
third
on
example.
essaye
What would
d'intervenir un
happen
peu, et
if we
dans ce
try
cadre-là,
to act
avec des
a
solutions
bit,
naturelles, donc ce qu'on
and
appelle
with
le nature-based
natural
solution.
solutions, what we call
Ici, c'est donc
natural-based
un modèle qui a
solutions?
été développé pour
So
cette région en
it's a
particulier,
model
la mer du
developed
Nord,
specifically for the
pour
North
regarder
Sea.
l'impact sur l'érosion du trait de côte.
Look at the
Si
evolution
on met en
of
place
the
des
erosion
marins.
on the
Donc,
coastal
on peut aussi
area
tester différents
of the
scénarios
Netherlands, and
avec,
we can actually
avec
test
cette plateforme.
different scenarios
Donc vous avez
thanks to
ici
this platform.
tester la
So here,
densité de l'herbier
these-
marin et puis sa
the-
position, si on le met
the
plutôt profond, très proche des
density
côtes,
of algae
et ce que ça va
and
donner
the
sur
density
des
near the
critères
coast.
et des indicateurs de
We
l'érosion.
can vary
Donc,
the
on a une
indicators
façon après
and
de tester deux scénarios et de
the
les comparer les uns avec
criteria
les autres,
of
avec,
erosion,
ici,
and
on
we can
teste
test
un
various
scénario
scenarios.
où on met une faible densité d'herbier marin, mais plutôt
So,
en profondeur ou un peu plus
This
proche.
is a
Et on
test
regarde
with a
ces
lower
indicateurs.
density and
Donc
a
ici, j'ai pas mis
test with
l'indice, mais il y a
bigger
un risque
density. You
d'érosion.
don't have the
Donc en jaune,
index, but
c'est
there's a
faible, et en
risk
rouge,
of
c'est
erosion. When
élevé.
it's yellow, it's
Et donc,
not
ce qui permet
that
de
high.
tester un
When it's
peu de
red,
façon
it's very
interactive,
high. So it's an interactive
genre
way of testing
d'impact.
these scenarios
Et
and
le
these
dernier
potential
exemple que je voulais vous
impacts.
présenter, c'était l'impact si on régule les
And the
pollutions plastiques.
final test
on a aussi,
is what about if we
grâce à, justement, aux
regulate
modèles globaux, on peut
pollution by
représenter
plastics, and
la
thanks to
connectivité
these
entre toutes
global
les zones
scenarios, we can
dans l'océan.
clearly
Et donc,
highlight the
en
connectivity
rajoutant
between the
là-dessus un
various
modèle de plastique,
areas in the ocean. And
et
if we
des
had
informations sur les sources
pollution
de
by
plastique,
plastics
donc soit
and
ils
the
viennent des
sources
rivières,
of
soit ils viennent de la
pollution
côte,
from
on peut
the
tester différents
rivers,
scénarios
from the
pour savoir,
coastline,
est-ce
we
qu'il vaut mieux
can
essayer
design
ramasser
different scenarios
les plastiques
and try
les trier dans
to
les rivières
ask
ou à
ourselves
la
if it's
côte, et
better
dans quelle
to
région en
try
particulier.
to pick
Et
up
donc ici, c'est
the
un
plastic
exemple avec ce qui arrive par
wastes
exemple sur
on
l'île de
the
Madère.
beaches, on the
Donc on a une
coasts.
représentation
So we
sur une échelle
had
de 2 ans
an example in Madeira.
d'où proviennent ces plastiques.
What happened,
Et
and
donc
we
on
have
peut tester un scénario si
a
par
2-year
exemple,
vision, so we can actually test
dans
a
cette
scenario.
simulation,
What would happen
on
in
réduit de
this
60%
simulation if we
l'apport
reduce by
des plastiques côtiers. De
60%
combien ça va
the
diminuer
plastic
combien de tonnes,
pollution
on estime
on
la
the coastline?
diminution
What would be
d'arrivée sur l'île de
the
Madère au
global
bout
reduction
de 2 ans.
on Madeira
Donc
Island
dans ce cas-là, ça fait
in the
33%
next
de
2 years?
diminution
It
par
represents a
exemple.
reduction by
Par contre, si on
33%.
diminue du même
But
pourcentage
if we
l'apport sur les
reduce
rivières, on obtient uniquement 8%.
pollution
Donc
in
ça
the
a aussi
rivers,
un
we
outil
only
de
see a
décision qui peut nous
decrease
permettre de trier
by 8%. So it's a good
différentes,
way maybe to just try
les
to
différents endroits
select the
et
best
prioriser ce qu'il faut
approaches
mettre en
and
place
give
comme
priority
action.
to some specific actions.
Donc voilà, j'ai
All
fini
right,
avec
that's
cette
it.
présentation brève
I'm done with my
des
short
possibilités
presentation,
des outils numériques qui sont
and I
utilisés
wanted to
ici
highlight the
pour tester différents
the
scénarios.
huge
Et donc
potential
dans
of
l'espace
these
Decide, donc juste à
digital
côté, il y a cette
tools. And so
démonstration
we
avec
have the
une
Decide
variété
space.
d'autres
So
cas tests et
demonstrations with various
scénarios
scenarios
possibles à
and also
tester
use
pour d'autres
cases
types d'applications, comme
for
par
other
exemple
applications.
les algues
For
sargasses dans
example,
l'Atlantique
the
tropical et leur
the
propagation
sargassum
dans le golfe du Mexique ou dans les Caraïbes,
and Gulf of Mexico,
un dashboard sur Costa Rica,
a dashboard
des
on Costa
applications
Rica,
pour l'aide à la navigation,
applications on how
aussi
to
tester différents
navigate.
scénarios de route
And we
et
also have
l'impact
different
sur l'émission
sea
et sur
routes and potential
l'économie,
impact on CO2
le carburant
emissions,
par exemple, ou
how to
un autre
save
exemple sur les
fuel
tortues
and so on. Example of
et le
on
lien
sea
entre la position des
turtles
tortues et
and
les zones de pêche.
the
On peut aussi tester.
the migrations of
Donc voilà,
turtles.
si vous voulez
All
avoir plus
right, so
d'informations aussi sur
if you
ce
want
qui est
more
fait dans le cadre
information
du projet
about
Edito,
what
vous
we
avez
do with the
plus
editor
d'informations sur
project.
Sphere.
So yeah, all the
Et les
information available
informations qui sont
thanks to this
toujours
QR
libres
code.
d'accès.
And these
Ah oui, oui.
information
Ouais, c'est ça.
are always
Toutes les
available
applications qui
to
sont
everyone.
développées
All
ici
the
sont accessibles
applications
sur la
we've
plateforme
developed
Edito
are
et
available on the
et
editor platform
peuvent être testées.
and can be
Merci
tested.
Yann.